As Wojtek said, I'm working for Nokia for the last 7 years, and I've been working as a specification engineer for the last 2 or 3 years. I don't even remember now. You might wonder, why does a specification guy talk to you on the testing challenges? However, I think that most of the challenges of the technology that we see in the specification and in the early stages of development of this technology, many of them will be very easily transferable to the test organization, to the test problem. Test has very big connection to the technology itself, even more than, for example, the implementation, writing the code. So whatever are the challenges of the technology are also the challenges of the testing itself. When I was preparing for this talk and I was talking to some fellow testers from our company, they pretty often were saying the same thing. So they said that 5G, it's pretty much the same as 4G. We have pretty much the same problems. And we have one big problem, which is the lack of phones. So basically, there is an operational problem that there's not enough tools. And apart from that, people tend to say that it's all the same. But if that, like both parts of that statement are partially true at least. But if it would be true that 5G is all the same as 4G was, then why all the hype about this technology? So before I go to the challenges of this technology, I want to first talk about this technology itself, what it is, what we think it will be in the next few years. I'll try to put some perspective of my own, and then I'll be talking about the challenges. So how many of you in this room are how many of you know what 5G is supposed to be? How many of you are able to fill out this triangle? Hands up. Very little hands. Okay. Okay, then let's go. There are like 3 separate streams or 3 wishes or whatever we call it in 5G. Number 1 is something we call enhanced mobile broadband. So this is this part of this technology in which we're talking about gigabits per second, about hundreds of megabits per second whenever needed in terms of this is this part when we are talking about ever increasing demand on mobile data. So this is this part that we are using the smartphones and we're trying to send as much data as possible. And this is this part that my colleagues are right, that this is very similar to LTE, only a bit different. It's like LTE, only a bit more. Why is that so? Well, if you want to have more throughput, then by the Shannon law, you basically need to have more bandwidth. Now, if you want to like put more bandwidth in the out in the world for the end users to use it, for the users of mobile phones to use it, then you have to look into new frequencies. Obviously, in most cases, we're talking about higher frequencies because that's the place where we have the new bandwidth. And to do that, you have to commercially implement a technique called beamforming, which maybe it's not something new, but it's something that it's hard to implement commercially. It's more expensive and there are problems with it. By this point, I could already show you that there are 2 problems with the testing, like the radio testing that we're trying to deliver at companies like Nokia or Ericsson. Number 1, if we are talking about gigabits per second, then how good is your test bed? Is your network in your laboratory already capable of running gigabits per second per unit under test? So that is one big challenge that everyone will have. And number 2 is testing over the air. While up until now it was easy to test things in cabled environments, with the beamforming, unfortunately, we have to switch to over-the-air testing, and that increases complexity, that increases the price, and that's even harder and more expensive. I will be going through that in a bit more detail later on. I want to focus about the technology at the beginning, right? So number two, the stream number two, is something I called here smart everything. This is this part in which we are talking about sensors, things that measure the temperature, humidity, that are small, cheap, use little energy, send little data, but are always connected and are pretty much everywhere. This is the place where we're talking about all the applications with artificial intelligence, with machine learning. This is the place where we are talking about all the startups or like mobile applications or startups, sorry. If now those smart everything cases cover, for example, smart houses, smart cities, traffic lights that are supposed to, be steering by themselves, or a smart fridge that is supposed to order food for us whenever we run out of some product. With all of those cases, if you think about the amount of software that we put around ourselves in our lives, software that changes the traffic lights, then on a software testing conference, does anyone see any problem with it? It's like one huge road sign saying we have a lot of good testing to be done. Number three is the stream number three is something I call instant everything. And here we're talking about things like virtual reality, connecting autonomous cars to each other. This is the part when we're talking about wireless factories that we can reframe overnight, and many more applications like this. There are practically only two technical requirements to this. Number one is latency, and number two is ultra reliability. And even though many people are talking about the radio latency, I want to talk about end-to-end latency later in this presentation. And for now, I want to just cover the ultra reliability for a short second. Ultra reliability should be meaning 5 nines or 6 nines. So just to remind you, 5 nines is over a year time of working of the device. You have a outage budget of 5 minutes, 5.5 minutes. And 6 nines means that if your device is working for a year, or your software is working for a year, you have an outage budget of 30 seconds per year. So that's not really much. Now, think for a second about your product or about the test bed you are working in, and think about 6 nines. And again, does this pose any software testing challenges to you? So those are like three most important parts of the 5G, and those like three critical streams that we see and that we think of today. Obviously today the first one is like most common and most popular because it's the easiest, earns the most money, and it's the easiest to implement like quickly. Together with that, there come a lot of different asks that mobile network operators have towards this technology, like private networking, like unlicensed access, like open radio access network, ONAP, ORAN, and many, many more. Now, to this point, I guess it's fairly simple. Then what's the problem with implementation of this technology? Well, first of all, this technology has some problems of its own that I will tell you what they are. Second of all, radio testing is always difficult, and it's more and more difficult. In this case, there are problems with the network architecture, or challenges around the network architecture. There is also some science fiction involved. And in the end, there are always human problems, like problems with our mindset, with our skill set, problems with our imagination of how we use the technology, and so on and so forth. So this technology has basically two serious problems. First is that it's very young. So the 3GPP standard came, what, year and a half ago, something like this. So it's very little time. And ever since this standard came out, everyone is trying to implement it as fast as possible. So trying to implement, huge radio standard over a period of 1 year or something like this, it's that's a very little time. And the problem is that everyone is doing that on their own, and everyone is trying to do it somehow. Everyone is trying to make out something of that standard. And in the end, everyone ends up doing it a bit differently. If we look at the first big benchmark of 5G, that I believe was in Korea in spring this year, when Korean operators launched their countrywide networks. It turned out that all of the vendors like Nokia, Ericsson, and everyone else provided that technology, but also everyone had very serious problem with the implementation of it. And the problem number two, and it's really pretty coupled with the first one, is that this technology is in very big rush. It's being implemented very quickly. It's being implemented faster than any other mobile network technology was implemented before. And the demand, the pace of the demand surprised everyone, I guess. Maybe the Chinese vendor was the most prepared, but basically everyone in the industry was pretty shocked. We as engineers tend to do things in our own pace, and we tend to be irritated when someone tells us to do our work faster and, for example, release our product even when it's not yet fully working in our minds. But in the end, it's not us, the engineers, to decide. It's the business that decides. And we might say it's bad that they, keep pushing us for the dates, but that's how it is, and that's how it's gonna be ever since. So we can either adapt or, quit the race. And mind you, this goes for everyone. So this goes both for equipment vendors. It goes for our vendors, like chipset vendors, FPGA vendors. It goes for phone vendors. It goes to producers of measuring equipment, and so on and so on. It even goes on team level. So if I'm working in specification and I am supposed to specify a subsequent release, like N+1 release, so I know the delta that I'm trying to introduce in my feature, but if the previous release is not working properly, then I don't have the baseline to adapt to apply the delta to. So it's hard for me, and some of you guys in this room are pushing me that my specification is bad, and that's okay. That's how it should work. But also as the testers, you will have to live with the fact that, for example, the specification is not always perfect or not always on time, and you will have to work with that too. But specification aside, let's get back to the testing or to the test bed issues. So basically with the radio, how many of you people in the room are testing radio or use radio in your setups? Fair amount of people, okay. So it might look fairly simple that you have a transmitter and a sender, a transmitter and a receiver, sorry. But the problem, like as I said in the beginning, the problem is with the phones. There are basically no 5G phones anywhere today. If there is any place on the globe that doesn't have a shortage of phones, that is T-Mobile or Verizon warehouses, where they are preparing for the Black Friday. That's where all the 5G phones are lying today. And that's definitely not our laboratories, so that's a bit tricky. How do we do that? Well, we have our own suppliers of the test equipment, like Qualcomm, Viavi, and other stuff. We have our own proprietary simulators, but each of those tools costs like tens and hundreds of thousands of dollars for a single phone, or maybe for a few phones, but working with one base station with one unit under test. And how do you go with large numbers here, right? So I do not have a good answer to this. I know that there's a like what some people do is that some companies provide both the base station and the phone in the same time. So you can do that, and that will work. But if you come with a different phone to that network, that will not be like really the implemented 5G standard. Additionally, for whatever reason I skipped it, I was supposed to say that those expensive phones, they provide different results. So how do you test when your test equipment, when your test bed gives you different test results? That's like, I don't know how to solve it, but I'm like only showing you what the challenges really are. If you think about the new radio and what I said in the beginning about the beamforming and the problems related to it, as said, the critical problem of the beamforming is that you cannot really test it in the cabled environment, so you have to go over the air in the testing. When you think over the air, this is what you should be thinking about. So all those large RF chambers that up until now were used only as a place where hardware testing was being run. So how do you use such environments right now? How do you build such environments to big scales? How do you put that in your laboratories so that how do you shrink it, make it smaller, and fit into your place that you work in? Additionally, like all the testing of that radio equipment was done, as I said, by a specific hardware teams, and the way it looked like was that we could pretty well separate the software side from the hardware side. What we had in between was some kind of mixer, amplifier, those kind of things, but that was like really close to the hardware. With the beamforming, the problem is that you cannot any longer like split those parts, because you need to steer the hardware by the software. You need to steer the beams by the software. So I see the like kind of skill set problem that you cannot be saying anymore that, oh, I'm a hardware tester, I'm a software tester. Those clear lines will be blurring out in the future. Generally, talking about the radio, I mean, I could talk about the radio testing for a long time, believe me, but that's not the point. It is so that where 5G is supposed to bring real change and real difference is not the radio, because we're just trying to put more bandwidth to it, But the real change in my mind will be happening in the network architecture. This is where the real revolution will be happening, okay? So up until now, what we had in 4G is that we had the base stations scattered all over the country, and we had one location where we had our core network, where the operator had the core network. And in 4G times, this was a big achievement, that we had one location that we could scale up or scale down, develop, and so on. We didn't have to develop in various places around the country. So what 5G does is, first of all, we exchange something called EPC to something called NGC, so next generation core. But that's only part of the problem, because if we are talking about end-to-end latencies, if we are talking about tens of or maybe hundreds of millisecond latencies end-to-end, then this model does not fit in any way. I mean, the light travels from Kraków to Warsaw in a second and travels back in another second. So if your application server, if your data for the user are in Warsaw and you are in Kraków, then you have 2-second latency at the start, right? So what you have to do is that you, or basically the operators, will have to start building, kind of spreading this core network down to many different locations in the country in a technology called, well, basically in the cloud, right? So edge cloud is something that will be of high value. And basically any cloud technologies, any usage of OpenStack, of Docker, Kubernetes, whatever else, if you don't know those technologies, you should be knowing them by now. Additionally, again, we're bringing even more and more software to our lives. So that brings another number of data collection points, data analysis points. So again, also any kind of machine learning, artificial intelligence, plain simple automation, those skills will be needed as well. And cloud is not only about, storing my pictures in Kraków because Warsaw is far away, or I dislike that city, or whatever else. Basically, all the concept behind the cloud is about enabling us, or enabling the industry, to provide new kind of services, new kind of software to the network and to the life of the end users as well. What those are, I do not know. I mean, I could be going on about various services or various use cases that I think there will be out there in few years. But if I picked anyone from you from the room and ask you to stage, like every one of you would have a good idea of what that can be. The clue point is that there will be a lot of new services that that might emerge in closer or further future. And if we understand all of that, if we understand what this technology is and what it provides us with, we will be better off, like maybe first of testing those services, and second of all, maybe even proposing those services. So the huge part of the 5G change that is coming is not about only the connectivity itself, because the connectivity is supposed to be, something like electricity plugs, right? It's supposed to be everywhere and accessible to everyone. But what will be important is what we do with it and what the services will be. And I think the biggest challenge that we all have is to be coming up with good services that will, well, that will first bring us money that we earn, and we will be able to develop them further on, but also that will be changing our lives. Thank you. Are there any questions, maybe?
Okay, so let's switch for a Slido for a moment and check what questions do we have. So let's go with the first question. There are some rumors that 5G can have bad influence on humans' health. What is your opinion? Should companies perform 5G health tests parallel to developing?
Should I be answering about the health or about whether we should pay for medical research? Which part of the question is valid?
I think like both. So
both. So first off, the influence of RF on living beings is unsure. I mean, I'm not saying there is no influence or that I don't know, that 5G is nothing bad. This influence is unconfirmed and statistical, I would say. So if you live very close to the base station, maybe there is some probabilistic chance that you will get some kind of disease. But in the same time, if you eat bad food, you will definitely be ill. Or if, I don't know, you sit all the day and don't do any sport, you will have health problems. So I believe that 5G is not the biggest of the health issues that we have in our lives today. That's number one. And should the companies perform 5G health tests parallel to developing? That is not a question to me. That is a question to the society, to the voters, and maybe to the policymakers, actually. For me personally, it probably would be bad because it would mean that there is more cost to the company that doesn't pay off, right? Like producing 5G would be more costly for us, but it wouldn't bring us technical advantages. So it's probably not something that any company would do without being forced to by a policy. Whether we should implement such policies or not, that's up to you guys here.
Okay, I think that was fair enough. So Wojtek, there is a book reward for you, so come up here after the lecture. And may we have the next question? If you have no or very limited number of UEs, how can you test capacity of base station, which is supposed to be hundreds or thousands of the UEs? The question from Michał.
I have no ideas, really. I mean, see, that's the part with this IoT stream, right? That we are saying that the numbers of the devices that we connect is going to millions, while I'm not sure if even in LTE, if anyone really tested those large numbers of IoT devices in the networks. See, some of the companies tend to switch their model to, like, you know, the end users will test it for us and they will feed back. So, and I guess I mean, it's not Nokia, but for example, Qualcomm does that all the time, right? I don't have a good answer, really. I'm sorry.
Okay, and let's go to another question. Does 5G need a new kind of tester? How to be smarter than all these smart things do testing it?
That's a very nice question. I like it. Yes, that's a question that I was kind of trying to pull out in the end. So how do you prepare for testing things that you don't know what they are? And my response will be such that if you are a good software tester, then you're fine. If you're a good tester with a good skill set, with this mindset of asking questions and going deeper and deeper why things work as they do, then you're fine. But if you're a checker rather than a tester, if you're a guy that, for example, has a specification and goes exactly with it and only sees what's written to be done, and you close your laptop after 8 hours and walk back home, then like being a checker's work can be done by some kind of automation, right? So I'm not telling you guys to sit overtime at work, okay? But I'm telling you to be open-minded testers and not like guys that are like doing A to B, A to C, checking day by day. I'm not sure if I'm clear enough in this answer.
Okay, I think we still have some time for 2 more questions. So let's go. Nowadays there is developed mainly interworking between LTE and 5G. When, in your opinion, full 5G networks will be available to end users, for example, in Europe? The question from Grzegorz Kosiec.
So that's a good question. So I'll tell you this. From what I hear, if you live in Korea, it is available to you. If you are in the US, so the life of a subscriber in US is such that if you have if you want to test 5G, commercial 5G, and you have like some kind of mobile phone, then first thing you have to do is to buy a 5G mod to that phone. That is basically the same size as the phone. It folds like to a twice as big device. Then you have to buy some very expensive, subscriber plan, and then you have to go to one of the particular cities that has 5G deployed today, and then in that city, you have to find a street where a 5G base station is deployed, and then if you sit like a few hundred meters from that stations or a few tens of meters from that stations, you will actually see 1 gigabit per second to your mobile phone. Now, do I need 1 gigabit per second to my phone? That's question number 1. And question number 2, how long will that last? I mean, if you walk a few hundred meters, that disappears, right? If you go around the corner, you fall back to LTE, most probably. That's because of the high frequencies that fade very quickly. So when will it be in Europe? I don't know. That depends on how the operators do. I guess there are some countries like Germany, Italy, Switzerland that have some deployments already. But in terms of when will it be as ubiquitous as LTE is today, that's still a few years away.
Okay, and time for the final question. What do you think is the biggest physical constraint for testing 5G, like money, space, etc.? The question from Darek.
If I was to put one, then I will go for the mindset and skill set once again. I will say once again, testing and not checking. And I think that's the main problem. I mean, all the rest, like lack of the tools, lack of the space, like lack of budgets, that's operational problems, right? We can handle them somehow. I mean, it's difficult and it's pain in the butt, but that's like operational problems. The real problem is the mindset, right? That we have to be curious and creative about how we do our work.
Okay, thank you, Wojtek. Please,
you.
great applause for the Wojtek here for his great lecture.